Hi everyone, today I'm going to show you how to connect this solar panel to this battery using a charge controller and then connecting this inverter so you can get mains power off grid. Hi, this is Everyday Prepper and welcome to the channel. First I'm going to talk about each individual component. So I'm going to go through the solar panel, going to go through the battery, I'm going to talk about the charge controller and then the inverter and all different types of those, and then we're going to put it all together really quickly to show you how you can get off-grid power as a backup in the event of a power outage. So first of all, the solar panel, I got this one the other day. This is a flexible 100 watt solar panel, so it's semi-flexible, and I've got it for the purposes of this demonstration just because it's a bit lighter and easier to carry around. And I was really excited to make this video, but when I first ordered this panel, I ended up receiving this doll instead, unfortunately, which I was considering hooking up to a battery, but I figured that there was probably some poor little girl somewhere who's disappointed in that she's received a solar panel, and she'd be gutted because she hasn't got a charge controller or a battery to hook it up to. So that's why I got this panel. This panel cost me about £70 something in the Black Friday deal. They are coming down in price quite rapidly. I think you can get a 100 watt solar panel now online on Amazon for about 50 something quid. So it's yeah, they are coming down a bit in price. Now the panel I've got here is this is a monocrystalline panel. The other type of panel is a polycrystalline panel. The main difference really is the monocrystallines are much more efficient, and that's because they have just one base of silicon. So the silicon's more pure, which means it can convert sunlight into electricity much more efficiently, and they work better in lower light conditions and cloudy days, which we get plenty of in the UK, which is why I always use monocrystalline. They cost a tiny bit more, but really the prices are coming down so fast, there's not a lot in it, to be honest. So that's the solar panel. So the battery I'm using today is a Marine battery. This is from my boat. It wasn't holding its voltage very well, but I've managed to revive it over the last couple of days just using this panel, so it'll do for the purposes of today. So it's a 12 volt 85 amp hour battery. I'll explain what that means in a sec. So with the 12 volt batteries, if you haven't ever done anything like this before, the beauty of doing 12 volt systems is that you're less likely to have the risk of electrocution. You'll see that I can touch each terminal, so that's the positive terminal and that's the negative terminal. You can touch those. Obviously you wouldn't want to be putting your finger in an AC socket plug, because that's extremely dangerous. It's AC and it's a much higher voltage. These I'm not getting any voltage through, but you don't want to touch them both at the same time, but you can, for purposes of attaching wiring to them, it's so much easier with a 12 volt. Now, a quick disclaimer, I'm not a qualified electrician, but I've got several years experience in setting up my own solar panel systems, all off grid. So because I'm not working directly with grid tied mains, you can do all of this as a DIY project essentially. So as I said, this is a Marine battery, and what that means is it's a deep cycle battery. It's a leisure battery, same as a leisure battery, as opposed to a car battery. And the big difference between the two is they're all less lead acid. There are other types of batteries which I'll go into, but the big difference with this is a car battery is designed for large amounts of current to be extracted from it quickly to start your car, start your engine, whereas these are designed to have a more steady flow, lower flow of current going out of them for a prolonged period of time, and then you charge them up over a suitable period of time, whereas a car battery is kind of one big blast of energy each time you start the car, whereas these are more for running lighting and other systems like that. So quite often on a boat you might have one that starts the engine and you have a separate battery for all the other leisure items like the GPS modules and the depth sounders and that kind of stuff. Same in an RV or a motorhome, you'd quite often have a two battery system. So this one, as I said, is at 85 amp hours. What that means is at 12 volts you've got potential energy here of, so 12 times 85 is 1020 watts. Using that calculation, you've got 1020 watts, which means that this could potentially run an item at 1000 watts or so for 1 hour. That's not entirely accurate because these batteries, you do not want to drain them more than 50%. So really you've got 500 watts that you could run, which is obviously half of that capacity, for 1 hour, and then you can work it out accordingly. So if you can do 500 watts for 1 hour, or you do 100 watts for 5 hours. That's assuming there's no charge going into it. Obviously, if there's charge going into it, you'll be able to run things for longer. Other types of battery, the big one on the market at the moment is the LiFePO batteries, which are lithium-ion potassium, I believe. They are very expensive compared to lead-acid batteries. So for this purpose of this demonstration, I'm using this one. It's much cheaper. But the LiFePO batteries are brilliant in that they can be discharged completely down to zero. So if you had an 85 amp hour battery at 12 volt in the LiFePO range, then you could use all of that. So you'd have 1,000 watts for an hour you'd be able to run, whereas this one you can only have half of it because you don't want to run it lower than half. They're a lot lighter as well, and some of them have battery monitoring systems in there. They're much more smart. So yeah, I think that's the way things are going really, and eventually I'll probably upgrade my whole system to LiFePO batteries, just because I can have half the amount of batteries, same capacity. They can run right down, and they're getting a lot more safe too, because they have been known to explode. So have lead acid batteries, to be fair. So that's the battery. So with this battery, I've put some battery terminals on each point, on the positive and the negative, and we're going to use that to attach the various components to. Right, I'm going to talk about the charge controller now. So this charge controller is a PWM charge controller, which is pulse width modulation. The other type of main charger on the market is an MPPT, which is a maximum power point tracking charge controller. The difference between the two, the major difference between the two, is that these are incredibly cheap. This one cost me about £7, so I bought a couple of them. I've got a spare as well, just in case, and always handy to have. The equivalent, this is a 20 amp charge controller, so this will work for, it's a 12 volt, and it will work for the purposes of what we're doing today. An MPPT equivalent might cost probably 50, 60 pounds or so, maybe even more, because they've got some completely different technology in there. So what this charge controller will do is you could connect your solar panel directly to your battery, and there are some solar panels that you can do that because they have regulators within them, but anything over really about 20 watts, you want to be using a charge controller. And the reason for that is your battery can only take so much current going into it, and with a solar panel of 100 watts, you've got at 12 volts, you've probably got about 8 amps going in. You don't really want necessarily all of that going into your battery at all times, especially when it's near full charge. So you have a charge controller, and then the solar panel will be connected to the charge controller will be connected to the battery. We're going to do all this in a second. And then with the pulse width modulation, the PWM charge controller, what they'll do is they will gradually send current into the battery until it's almost full, and then it will just pulse it with like a trickle charge until it's right up to capacity. That's the idea with those. MPPT chargers, what they do is they maximize, they take whatever voltage is coming in from the solar panel, and they can step up and step down the voltage or step up and step down the current according to what needs to go into the battery. So it'll be a much more efficient way of charging. Now I use MPPT chargers for my home-based off-grid solar power system, just because being in the UK, I want to just maximise the efficiency as best I possibly can. So that's the charge controller. This one's got a couple of little USB sockets on there as well. So it's got an input for the solar panel, so a positive and negative. It's got a positive and negative for the battery, and it's got a load output, positive and negative as well, which I'm going to connect a light to just to demonstrate today. And as I say, it's got some USB sockets on here. I don't think they're particularly great. I think they're about sort of one amp, so they probably won't charge an iPhone, but we can get around that with some other kit. And then lastly, we have the inverter. This inverter is only a little one. It's a 300 watt 12 volt inverter, so this will connect to the system to be able to plug in mains appliance into the main socket on the back there. So you just plug that in there, and what it does, it just converts 12 volt into 230 volts. So it would be the same as if you were running from plugging something in at home, and give you the same electricity that you would get from home, really. So you can convert your solar panel energy into mains power. That's the whole idea. Now there are several different types of inverter on the market. This one is what we call a pure sine wave inverter, and I would recommend that. They are more expensive, and there's a couple of different types of inverter. You've got a modified sine wave and other variations on that, but you've also got the pure sine wave. The reason we go for pure sine wave is because the sine wave is like the AC current that comes out of your sockets at home. Is a very smooth curve, smoothly done. I'm not going to go into the details of that, but what this will do is match what's coming out of your home socket. Other sine wave inverters, like modified sine wave inverters, are mimicking that sine wave, and some electronics don't like that kind of signal coming out. So I always go for pure sine wave. It's just much more. It'll run anything. So what I've done, just to set up, I'm going to wire everything up now. We've got on the inverter, I've just put a couple of cables on here. It came with a cigarette lighter socket that was just connected onto the positive and negative there, and you can plug that in your car, and this is designed to be used in the car. So what I've done, I've taken that off, and I've just put a couple of cables on here, coloured for coordination, and some lugs on the end to go onto the battery. So first of all, we need to hook up the solar panel to the battery. And the way we're going to do that is via the charge controller. Now with the charge controller, with all of these, I know there are some that you can do it a slightly different way around, but in my experience, most of these charge controllers, you must always connect the battery to the charge controller first before you attach the solar panel. I did one a couple of years ago where I attached the solar panel to the charge controller without putting the battery on there first, and it blew it. It just blew the whole thing. And that was one like this. Always connect your battery to your charge controller first. So we're going to do that quickly now. And then what we're going to do is now I've got black cables for both of these. I didn't have another red cable that I could use. Make sure we've got the right wires going into the correct terminals. Got a little red and a green marker on here. Red for positive, green for negative. That should work out nicely. Just tighten that up there. Okay, another one. Now obviously I want to make sure that I don't touch these two cables together when they're attached. So if you're new to the channel, my name is Steve. I'm a prepper and outdoor enthusiast. I make videos about prepping and homesteading, and also practical videos like this one. So if you like the information in this video today, please consider subscribing for more content like this. Okay, so we're going to hook this up. I've connected the terminals to the battery. We're going to hook this up to the charge controller now. So a charge controller has a little battery icon, it has a solar panel icon and a load icon. There's a little light bulb. So I'm putting the positive of the battery into the positive of the battery icon on the charge controller. Doesn't matter which one you do first. You can put the negative in, you can put the positive in, just make sure they go in the right place. Right, that's the positive in. Now we're going to put the negative in. As soon as I've done that, the charge controller is now lit up, so it's powered from the battery. As long as there's at least 9 volts in your battery, which on a 12 volt battery, if it's gone down to 9 volts, you've got problems. So hopefully you can see that there is now, it's showing 12.4. This battery's a little bit low. I've been trying to revive it, but it'll work fine for the purposes of what we want to do today. That's the charge controller now working. It has a little icon there of the battery, the charge state of the battery. And then the load icon, it's actually trying to put 12 volts out of the load there. So if I just turn that load off for a second, and then what we'll do is we'll attach a load, which will be this little light. This is a little 12 volt LED light. It's about 20 watts. So I put the load on, and then the light goes on. Simple as that, right? So we're already powering 12 volt system off grid from your battery, and that's without the solar panel even connected. Now obviously if I had that on and left that on for a considerable period of time, eventually the battery would start to lose its charge and give up. So this is where you need your solar panel to just keep it topped up. And you can run a whole load of lighting systems. I've got lighting systems all around my house that are linked to my solar system as a backup. Right, so now we're going to attach the solar panel to the charge controller. So we've got the battery connected to the charge controller. I've got the load attached. You don't have to use the load. I'm just doing it for demonstration. Now the solar panel comes with a positive and a negative terminal. And you have these cables. Pretty much all solar panels you get on the market, certainly off-grid ones, have these connectors on. So you'll have positive there, and that's the negative. Now if I was to put this in, say, my conservatory or in the sunlight, and then use a multimeter and just connect these two to the multimeter, you'll get sort of anything up to 22 volts coming out of it. That's a good way of just testing your panel. I can't really do that now because I'm stuck behind this desk doing this demonstration. So what we're going to do is we're going to connect to the battery. Now I can't connect to the charge controller, but I can't do that with these plugs, so I need some extension cables. So I've got these extension cables here, which I haven't stripped yet, so I need to strip those. So what we'll do is we'll connect those to the solar panel, and we're just going to plug that in there. So you've got a female socket there, a male socket there, and we're just going to plug the two in. That's that one done. And it's the other way around for the negative terminal. We've got an extension lead with a male socket on, and the panel comes with a female socket for the negative. So plug those in as well. That's it. That's done. And then I'm going to strip these ends off just so they can go into the charge controller. Okay, right, so now we get the charge controller. I think what I'll do is I'll just take that load off because it's getting in the way a little bit. What I could have done here is also connected the inverter to the battery, so that you don't need the solar panel necessarily connected to the battery to use the inverter. But of course, if you're using, I mean, this is a 300 watt. If I'm using, even a couple of 100 watts on there, it's not going to last very long on the battery without further charging. So ideally, before you use an inverter on a battery, you really want a solar panel or some kind of input coming into the battery so it doesn't completely die on you. We've got the positive end of the solar extension, and that goes in the positive on here for the panel. Screw that in. Nice and tight. Same with negative. And that will just go into the negative. Screw that in tight. Now it's not registering the solar panel on the charge controller, and that's because the solar panel is currently in the dark and not getting any sunlight. But as soon as I move it into something where there's light, right, so just holding it up here to the light, you can see now the charge controller is recognizing that there's something going into the something coming from the solar panel, and that's just with domestic lighting. That won't charge your battery. You really need UV light, but it's just to show you that it's registering. It's quite sensitive equipment. So that's all working. It's all hooked up well. It's all working nicely. And then now we're going to connect the inverter. Now I've done a schoolboy error here. I should have connected the inverter first because the way I've set up the lugs, I need to undo the charge controller. Now if I undo the charge controller from the battery, what's going to happen is I'm going to blow the charge controller potentially because I've got only the solar panel connected to the charge controller. So what I'm going to do is just going to unplug, really simple, just going to unplug the solar panel from the extension lead. So there's no connection there now, and that just makes it easier. So now I can work on the battery, and it doesn't matter if I undo the battery now from the charge controller, just to get this inverter wired up. So we're going to do red to red. Do that quickly on here. Right, so now we have the charge controller is connected to the battery, or the battery is connected to the charge controller. The charge controller is on and showing voltage. We have the inverter connected to the battery. If I turn the inverter on, we've got power. It's immediately dropped the voltage on the charge controller, and that's because the inverter does use up some energy to just run. Also, I think it has a little fan on it as well. So that would actually run. I could plug something into that now without the solar panel connected. So I'll turn that off for a sec. I'm going to connect the solar panel back up. Okay, so we've got the extension cable for the solar panel on the positive terminal. I'm just going to plug that back in now. Now that the battery is connected to the charge controller, I'm just going to plug the solar panel back in. So that's all in. It's not really charging anything because it's not in sunlight. And then we're going to use the inverter just to demonstrate. So what I've got here is I've got a little, this is like a little greenhouse heater. I think it's about 40 watts or so, 30-40 watts. Just to show you this working from mains. So rather than plugging it directly into here, because you won't be able to see it working because it just gets warm. So I'm going to plug this monitor into the inverter, and that's going to give you a readout as to what wattage is coming out of there. So we're going to plug that in, turn the inverter on, and then right, so that's lit up my my monitor, and then I'm going to just plug the heater in. That's in there, so that's now gone up to 44 watts. So I'm running 44 watts. My battery has now gone down, because this battery is on its way out. The battery has now gone down to 12 volts because there's a draw of current on the battery. But it's heating up. This will be heating up now. It's actually getting warm already. So we've got 44 watts coming out of the inverter. And there you go. If I had that 100 watt panel on there, 100 watts coming through, let's say on a really bright day I've got, I don't know, maybe nearly 100 watts, maybe even if I've got 50 watts, it would run this thing absolutely fine, and we'd have no problem. So let's turn that off. This inverter has already has its own fuse on, and it also has a voltage alarm. So if the voltage on the battery goes too low, then the inverter will trigger an alarm for a little while, and then it will just turn itself off, so it doesn't drain your battery too far. Because if your battery gets drained too far down, you can get what's called sulfurization. I believe it's called sulfurization, where sulfur builds up on the plates inside the battery on these things, and it just makes charging it really difficult. So with this system, I haven't actually wired in any fuses, and that would be recommended that you have some kind of fuse, maybe about a 10 amp fuse. I mean, this panel will be kicking out about 8 amps of current. If you expanded it up to have more panels, depending on how you wire it, this is subject of another video, whether you wire them in series or parallel, you could get 20 amps, 30 amps, whatever. So make sure you've got the appropriate fuse between the solar panel and the charge controller. The charge controller does have its own fuse system, and I ran a system for years with no fuses at all. I probably should have done, but they do have fuses inside them, but it's just handy to have some kind of isolation point between the solar panels and the charge controller, and also between the battery and the inverter as well, so that you can shut that off if need be, or if there's a surge of current, then it's not going to blow everything up. Fuses are a good idea. So there you go. Hopefully that's been useful. If you like what you've seen in this video, please hit the like button and consider subscribing for more content like this. So thanks for watching, and stay prepared.